Hey students, this is lesson 4.5. In this lesson, we are going to use and apply properties of isosceles and equilateral triangles. Go ahead and do the vocab here. I'll check back with you. All right, here's the theorems we're going to be using here. Isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So basically the base angles in an isosceles triangle are congruent. And theorem 4.4, the converse of that, if you have two base angles that are congruent, then the sides opposite those angles are congruent. Theorem 4.5, if the line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So number 5, if PQ is congruent to RQ in triangle PQR, then angle P is congruent to angle R. And then number 6, underline the correct theorem number. So because these angles are the same right there, that's a perpendicular bisector, so that means that bisecting means that these two lengths are the same, and that would be theorem 4.5. All right, so let's use this isosceles triangle theorem. Is GK congruent to HK? So GK is that one, HK is that one. And we're going to say yes, they are, because we can see that angle H is congruent to angle G. And so because those two angles are congruent, then the sides that are opposite those angles are congruent. So HGK is congruent to HK. And that's by the converse of the isosceles triangle theorem. Let's call that converse ITT. So ITT is going to be our isosceles triangle theorem. Okay. Second one is HL congruent to JK. HL, and so HL this one, JK that one. The only way that would happen is if this angle is congruent to this angle, and then we could subtract, and this angle is congruent to this angle, then we could subtract equal parts and say that they're equal. So, but that isn't true. No. We would need angle L congruent to angle J. All right, I'm going to let you try applying that isosceles triangle theorem. All right, so what is the value of x? We're going to use the isosceles triangle theorem, one of them, to figure that out here. I think we can say that 7x minus 10 is equal to 3x plus 6. And that is because of the converse of the isosceles triangle theorem. Let's call that CITT, converse isosceles triangle theorem. If I subtract 3x from both sides, I get 4x minus 10 equals 6. Add 10 to both sides, I get 4x equals 16. Divide both sides by 4, and I get x equals 4. All right, you try that. some corollaries to those theorems deal with equilateral triangles. If the triangle is equilateral, then it is also equiangular. If a triangle is equiangular, then it is also equilateral. So which of those theorems is this, or which of those corollaries is this illustrating? So we have equal sides, that's equilateral. Then that gives us equiangular, and that would be 4, 3. All right, so in the diagram, triangle PLN is congruent to triangle LNS. What is the measure of angle S in the figure below? All right, what we're going to do is say that the measure of angle P equals the measure of angle PNL. And that is because of the isosceles triangle theorem. So we're just using that. And since that's true, we can say that the measure of angle 2 times the measure of angle P plus 50 is equal to 180. And that's just the triangle angle sum theorem. So 2 times the measure of angle P is equal to 180 minus 50, which is 130. So the measure of angle P is equal to 130 divided by 2, which is 65. Now, angle S is congruent to angle PNL, and that's because of this. The 2 triangles are congruent, so corresponding parts of congruent polygons are congruent. So, and we know that angle PNL is equal to the measure of angle P, and the measure of angle P is 65, so we can say that angle S, measure of angle S equals 65, and that's by substitution. All right, you try that. Basically, we just have a whole bunch of base angles that are congruent from our 3 congruent triangles, and that they're isosceles triangles, and that allows us to find the solution. All right, that's it for this lesson. Do the lesson check, and we'll talk about it next time we meet in class.